Hello, my friends, and welcome. Today I want to talk about one of the most important concepts in all of algebra, even in all of mathematics, factoring, but with particular emphasis on algebra. So get some lined notebook paper to work on, because when you're thinking, you should be writing, because the writing gives form and structure to your thoughts. And so let me share my desktop with you and we will begin. Okay, so before we begin, let's actually play just kind of a little bit of a game here. So let's see. Let's do a before and after. And let's do a couple things here. If I said 2 plus 3 before, you would say after. Well, that's 5. What if I said 4 plus 10? You would say, well, that's 14, right? Easy. What if I said I want the after to be 12, and I want one of these pieces here to be, say, I don't know, 9. 9 plus what? Your answer would then hopefully be 3, right? So if I give you the before, you can probably give me the after. And if I give you the after and maybe a couple pieces of the before, you can maybe find another one. Is there another way that I could do, say, I don't know, equal to 12? If I just left it open-ended, can you come up with different ways to add together to get 12? Yeah, maybe even something like this. How about -2 and 14? Would that work? Right? So you can do some befores if I give you the afters. Let me change this a little bit and let me say now, still doing the same thing, still doing a before and an after. What if I said 2 times 3? You would say, well, that's 6. Okay, so then what if I said something like, I don't know, 4 times something is equal to 20? You would say, well, I can give you a part of the before, that would be 5, right? What if I gave you the entire after? Let's do 12 again. And I left it open-ended for you. Could you come up with, I don't know, 3 times 4? Right? Maybe there's another way to do that. What other ways can you multiply two things together and get 12? Well, how about 1 and 12? Okay. What about something else? Oh, we could do something like a negative. We could do that. What about, I'm going to show you a special one here. Let's have a little fun. I'm going to mess with your mind. What if I said 17? 17 times what is 12? This one's actually fairly easy if you think about fractions. How about 12 17ths, eh? Right, because don't the 17ths cancel and then you're left with the 12 afterwards? Yeah, whatever you wanted to get rid of, you put in the denominator, and then whatever you want to keep, you put in the numerator. Good. Okay, so let's keep along this before and after path of multiplication. What if I said 3x plus 6? Oh, algebra time now. And I gave you that one of them was a 3. Could you tell me what I would multiply by now to get 3x plus 6? Hopefully you can see that that's going to be an x plus a 2. Is that right? If I use the distributive property on this, if I take 3 times x, does that give me 3x? And if I take 3 times 2, does that give me 6? Yes. And so what we are doing here is we are factoring. So the answer to these questions are products. The answer to a multiplication question is a product. What are the things that you multiplied? These things over here are factors. And so then to factor as a verb means that you're going to write the product as a multiplication question. You're kind of going to go backwards with multiplying. The way to really say this is unmultiply. but that sounds so crude. No, it means factoring means you're going to write them as factors. You're going to take the product and you're going to reverse multiply, not divide. It's not division. Don't ever say that factoring is division. It's not. It's backwards multiplying. You're undistributing, unmultiplying. And the proper term for that is factoring. All right, so then here's what's going on. We're going backwards. You're being given the after. I almost wrote before. You're being given the after, and you have to go the other direction to find the before. And the first way to do that is to factor out the greatest common factor. So if I did something like, let's see here, 12x squared, I'll say plus 3x. Can I write that as a multiplication question? In other words, can I say that this is somehow equal to things that are being multiplied? And the first thing to look at here is to notice that I've got two terms. I've got a 12x squared and then I've got a 3x over here. Is there a number that multiplies into both 12 and also into 3? Yes, the number that multiplies into those, the greatest common factor of the number is going to be a 3. And then is there a greatest common factor of the x squared and the x? And actually the variables are going to be easy. Do they both have a common factor of x? Yes, they do. What's the largest factor that's common to them? Just a single x. Now, the question then is, what do I have left over after I factor, not divide, after I factor a 3x out of 12x squared and out of 3x? Well, the question might be, what do I multiply 3x by to then get 12x squared? Hopefully you can see that the number part of that is going to be a 4, because 3 times 4 is 12. But what do I multiply x by to get x squared? It would be an x. But now I got this other term in here. I also have to multiply 3x by something into a second position in order to give me a 3x. What do I multiply 3x by to get 3x over here? Be careful on this one now. It would be a plus 1. And somebody's going to say, well, if you factor it out, doesn't it just disappear? Well, you factored everything out, but you still have to hold the place. It might even be better if we wrote this instead of sideways, if we wrote it down. Let me write this down. Go down the column here. What do I factor out of both a 12 and a 3? That would factor out as a 3. What do I factor out of an x squared and an x? That would be an x. And now what remains after I factor those things out? 3x times what in this position right here gives me a 12x squared. That would be a 4x. But then also don't forget, there's two terms here, so I've got to have another term here. 3x times what gives me a 3x? I have to have the 1 there as just a placeholder. If I didn't have the 1 there as the placeholder, if I just said, hey, it's 4x, because I took everything away out of that second term. If I were to multiply this now if I were to multiply 3x times 4x, I would only get the first term. I would just get 12x squared and nothing else. But I've got to get also a plus 3x, so I have to have then a plus 1 there to hold the place, okay? This is now factored. And so you can double check by multiplying it in. If I multiplied 3x into that group, would I get 12x squared plus 3x? And yes, I would. So let's try another one. Always looking for the greatest common factor first. Let's try this one. Let's try 6x to the 5th minus 8x to the 4th plus 2x cubed. Okay, 3 terms now. So I'm looking for the sign first, and then I'm going to look for the number, which is the coefficient, and then I'll look for the variables in order. Now the sign, sometimes you need to factor a negative out, and we'll get to that in a minute. But in this case, since my first term is positive, I'm not really going to look for the sign. Let me look for the number. What's the greatest common factor of the numbers of 6 and 8 and 2? What number will multiply into a 6 and 8 and a 2? If you say 6, 6 will not multiply into 8, and 6 will not multiply into 2. It's got to be a multiple here. So what is the, no, sorry, I said that wrong. Hang on, let me get this straight. Multiple is something that you multiply into. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. Those are multiples of 6. I'm looking for the factor, the number that will multiply into those things. No, I said it right. I said it right. It's important to think about those terms. Sorry, I had a moment. The greatest common factor of 6 and 8 and 2 is 2, because that's the number that will multiply into all of those. So I'm going to factor out a 2. Now, do they share variables? Yes, they all share an x. But what's the largest number of x's that I can remove by factoring? That would be an x cubed. The variables are actually easy. Find the one with the smallest exponent on there. That's the one that you pull out. Okay, the smallest exponent of all the x's is going to be cube. So that's what I factor out. Now, what remains after I factor that and remove that out? Or in other words, what do I multiply 2x cubed by in this group so that I get these terms then in the end? 2x cubed times what gives me a 6x to the 5th? Well, 2 times what gives me 6? That would be a 3. And then what do I multiply x squared by to get x to the 5th? Hopefully you can see that that's going to be x squared, or x cubed by to get x to the 5th. All right, now the next term, we copy down the sign. It didn't factor out a sign, so it's going to be negative. 2 times what gives me 8? That would be 4. And x cubed times what gives me x to the 4th? That would be an x. All right, and then what do I multiply a 2x cubed by to give myself a 2x cubed? That would be a plus 1. Don't forget the plus 1. If you factor everything out of that last term, you still have to have the 1 to hold the place. All righty, and now that's as far as we'll go for this one, although maybe, does this one factor down even more? It might. But that will be for a later lesson. That's as far as I want to go on that one. Okay, I've factored out the greatest common factor. Let's look now at this one. I'll do one with some multivariables. Let's do 10a squared b cubed plus 5ab squared minus 15 ab cubed. Okay, 3 terms again here. All right, so do the number first. Is there a common factor of 10 and 5 and 15? Which number will multiply into all of those? Hopefully you see by now that that would be a 5, but I'm not finished yet. Now let me do the variables in a. Do all of them share an a? Yes, here's an a, there's an a, there's an a. They all share an a. What is the largest number of a's that they can all give up, or they can all donate? It will be the a with the smallest exponent, which is going to be a to the first out of both of those, so it's going to be a single a. The most that all of them can give is a single a, because those second 2 terms, that's all they have is a single a. What about now b's? Do I have a b? I got a b here, I got a b there, and I got a b there. What's the smallest exponent on any b? It would be this one right here, b squared. So that's the what I factor out, b squared. Now I've got to decide what's left after I factor that out. If I factor a 5 out of a 10, I'm on the first term right here. What's left? A 2. If I remove 1a from a squared, what's left? A single a. And if I remove a b squared from b cubed, I take 2 out, how many are left? 1. There we go, 2ab. The sign comes down in here next, that's a plus. Okay. Now, if I factor a 5 out of a 5, what's left? 1 as a number. But if I take an a out of a single a, isn't that everything there too? And if I take a b squared out of everything there, isn't that? So this one's just a 1 that remains, just a placeholder, because I have to have that middle position. Okay. Then minus, now on to the last one right here. 15, if I factor a 5 out, what's left? That would be a 3. Because 3 times 5 is 15. And if I remove 1a, and I only had 1a to begin with right there, what do I have left? No a's. And if I remove 2 b's, a b squared, what do I have left? That would be just a single b. So there we go. There's my final factored part, or at least the greatest common factor. Maybe you could factor that middle one down a little bit farther. I don't see it easily, so probably not. There we go. Let me shift gears now. Let me do something maybe a little bit different. Same principle, different structure. What if I said 2 times q plus 3x also times q? And I've written them a little bit strangely there with parentheses, but I hope you'll see why in a second. Do they have a common factor? Yes, both of those terms share a q. So factor that out. Factor out a q. And again, I'm putting it in parentheses. What remains after I factor out that q, after I maybe strike that out there? What's left? That would be a 2 plus a 3x. There we go. It's factored. You say, boy, that's kind of going backwards. That one's too simple. Well, not really, because I don't care about q. I do care about u, but I don't care about q. The q there was just a placeholder. What if I had something that looked like this? What if I had not just a monomial, but a binomial, x plus 3 in that position and an x plus 3 in that position? Does that change how I'm factoring? Not really. I've got a term here that's got an x plus 3 as a factor, and then I've got plus another term here that's got an x plus 3 as a factor. They both share the x plus 3. X plus 3 is a common factor, so factor it out. So it just becomes x plus 3 out there. So your greatest common factor can be a binomial, a single term, monomial, or a binomial, 2 terms. You can factor out more than just a single monomial term. You can factor out a binomial. And that's going to become useful now when we do the next thing, which is factor by grouping. Okay, so new idea. Let's do a 4-term one. 16ab minus 8a minus 6b plus 3. Okay, 4 terms now. Do I have a common factor? No, there's not a single number that multiplies into 16, 8, 6, and 3. Well, 1 does, but 1 doesn't do anything for you. Do they all share a common variable? No. They don't all have A's. They don't all have B's. So it looks like it's stuck, but it's not. Here's what I'm going to do. I got 4 terms. I'm going to kind of break it down the middle into groups of 2, and I'll do my little phantom separation there with a little dashed line. And all I want to do, see if I can do this right on the iPad. All I want to do is look at the 2 on the left. Just the group of 2 on the left. Do they share a common factor? Yeah, they do. I can factor an 8 as a number and also an A out of that. What remains if I do that? I think I would get a 2b. Or not 2b. A little Shakespeare for you. A 2b minus what? What's left over after I factor an 8a out of an 8a? That would be a 1. Right? Now I'm going to go look at the other side. And in hope, I have to see if I get this same group right here. Do I get this same group right here? I'm going to go ahead and write it over there in the expectation that it will work. That's maybe a little Mr. Marsh exclusive. I've never seen that taught anywhere, but it helps. If I come over here now and I write down the same group I had over here in hopes that it will factor, just write the same thing down here. Now let me look. Can I factor something out of negative 6b that gives me a 2b? I think so. What times 2b is negative 6b? Would that be a negative 3? Let me check. If I do a negative 3 times 2b, does that give me a negative 6b? I think that it does. And then if I distribute this negative 3 into the negative 1, does that give me a positive 3? Yeah, see, it worked. Okay, now pull back out and look at the big picture. Notice I'm including the one above it too because it's relevant. Do I have a common factor between the 2 sides? Yes, I do. I've got a single subtraction sign right here, so it's this whole group, then minus this. Do they share a common factor? Here's a 2b minus 1. There's also a 2b minus 1. Factor that out. That's now the common factor. The common factor is going to be 2b minus 1. And after I have removed those, I'm striking those out, what remains? It's there in red. Can you see it? It's an 8a minus 3. There we go. I have factored it by grouping. Factoring by grouping means you're going to separate the beginning expression into groups. Usually it's down the middle, but every once in a while you want like a group of 1 and a group of 3, but that's more complicated. Split down the middle. 4 terms is usually your indicator that you need to factor by grouping. Split it into a group of 2 on the left and a group of 2 on the right. And sometimes you might even have to rearrange the pieces around to get what you need in order to do that. And notice we had to factor a negative out of that right-hand side, a negative 3. When you factor a negative out, it changes the sign of the term that's here. Factored a negative 3 out, so it changed the sign. What was positive becomes negative. All right, now, let's try one more. This is the one like you're going to see coming up. We'll do x cubed minus 2x squared minus 3x plus 6. Okay, factor this one, which means basically to unmultiply it, to write it as a multiplication question. Do I have a greatest common factor of numbers? No. Do I have a greatest common factor of variables? Also no. But I've got 4 terms. So let me split it down the middle. Here's my phantom separation here. Don't use parentheses. If you use parentheses to group the things, you have changed it into a multiplication problem, and it doesn't multiply. So that's my little phantom break there. And let me factor the left 2. Do I have a common factor there? Yes, it would be x squared. What do I need to factor out of? And it needs to be the greatest common factor. What do I have left remaining after I factor out an x squared? That would be an x minus 2. Okay? In hope, let me see over here if I can factor something out and leave me an x minus 2. And I'm looking at the first term there. What do I factor out of negative 3x to give me a positive x? Do you see that that would be a negative 3? You got to have a sign there with it, a negative 3. If it's a positive, you have to write a plus. You got to have a sign there with that thing that you factor out. I think so, because if I multiply in, is negative 3 times x negative 3x? Yes, it is. Is negative 3 times negative 2, is that positive 6? Yes, it is. Good. So now what I've got for my common factor is the binomial x minus 2. So factor that out. X minus 2 comes out. And then what remains after I've removed that? Hopefully you can see it's going to be an x squared minus 3. Okay, there we go. All right, factoring. Number one thing you're always going to look for. Always look for the greatest common factor. And if you've got 4 terms, look for factor by grouping. I think that is it. May your day be merry and bright, and may all your mathematics be right.